Okay, here's your e-learning. This is going to be 3.1 and 3.2. So when we're done with 3.1, don't stop listening. Okay, so this is 3.1 is really simple. 3.2 is really simple. This is why I'm putting them together. So 3.1 is about population versus sample population. And it's really simple. The issue is, do you understand what it is you're finding when you do a sample of the population? So the population is the total. It's everything. The sample population is just a part of the population. Okay? So if you say you wanted to understand more about how Indiana voted, you would have to take the whole population. Or you could just take a sample of population like 1,000 people. The question is, are the 1,000 people biased? Are they the correct ones? Are they unbiased? Meaning, if you just went to a school and took 1,000 18-year-olds that could vote and asked them how they voted, would that be a good sample of the total population? And the answer to that would be no. So you'd have to do a good job trying to get a variety of your sample population. Okay? So, and that's really what 3.1 is. So we want your sample population to be random. So these are just words that we need to make sure you understand. Okay? So let's address just a couple things here. If you were to take two random sample populations, would they be exactly the same? And the answer is no. Technically speaking, you have to do the whole population if you want to get a true and accurate set of data. Okay, so you can't do that with a whole population of people. So we do random variety sample populations, and hopefully those those sample populations are going to be representative of the whole population. That's basically 3.1. You're going to be answering in your homework saying, hey, this is a good sample population, this is not a good sample population, and which one is better? Is this a total population or is it a sample population? And where you take your population, sample population is important too. If you only do your school, is that representative of all schools? And the answer to that would be no. So we need to make sure that we understand when something is a good random variety of the population. Okay, so be aware of that, and we will answer questions on Monday over your responses. Make sure you turn in whatever it is you've done on your homework into Google Classroom. So I will send that out separately from this video. So let's look at 3.2. Okay, 3.2, one of the things we need to know is what we call a margin of error. So I'm really just pointing out just the most important things that you have in each of these lessons that you really do need to make sure you know the vocabulary of. So margin of error is something like this. If I say that I want to ask how many students like Snickers bars, okay, and we look at the population of students, and we take a random sample of it, a random sample, freshmen, sophomore, juniors, and seniors, and we look at that, and it comes out to, and we find that 75% of all students like Snickers, with a plus or minus, or we should just in general say, let's say 4% margin of error. Okay, so what you do is you add or subtract that margin of error from the information given. So we take 75 minus 4 and 75 plus 4. So that would be between 71 and 79% if you, as showing how accurate that it really would be. Okay, so between 71 and 79% of the student population likes Snickers. Okay, so I totally made that up. I don't know what the true numbers are. So that's what margin of error is. You add or subtract it from the main number that is given. Okay, so let's make sure we have this. This right here is what we call a confidence interval. Okay, now margin of error accounts for the sampling variability, meaning obviously this is not fixed. 71 to 79 is not a fixed amount. That's what we call sampling variability. Okay, that doesn't cover any mistakes that are in collecting the data. Okay, so if you have larger samples, then you have a smaller margin of error. Okay, if you have 1,000 people and you only randomly sample 5 people, then you have a very large margin of error. Okay, so let's check for some understanding here, and then we'll be done. All right. Okay, so we're going to use the SAT as an example. So we have a researcher wondered what the average SAT score is for all current students at the University of Michigan. So SAT scores at Michigan. Okay, and you have a random sample of 30 students. And the report of the average SAT score for, let's see, average score for all students, is 1,222. That's the average score with a margin of error of 30. Okay, so question number 1 would be, is the average of 1,222 reported by this person calculated from a sample or the whole population? Well, we've already been told it was from a sample. They did not go and look at every score of all the Michigan students. Okay, so use the margin of error to give an interval of possible values for the true mean. All right, so we're looking at this information right here. So 1,222 minus 30 and 1,222 plus 30. So this is what you do with the margin of error. So let's do that calculation. And so we subtract 30, we're going to get 1,198. Wait, I'm sorry, that's not right. 1192, sorry. And 1222 plus 30 is 1252. Okay, so these are the confidence intervals here between 1192 and 1252. Okay, so do we know that every student, do we know every student at the University of Michigan's SAT score is going to be between those? And the answer would be no. We don't know that every student is going to fall between that. So this is, the 1,222 was an average, which means you could have somebody that gets a 200. Okay, so no, we don't know that every student's going to fall between those values. So this is what I meant by understanding what it is you're finding. All right, number 4. Why do we need to report a margin of error along the estimate? Okay, so some students might have lied. Is that true? No, we don't think that students have lied. Okay, the researcher may have recorded the wrong values. Well, no, we don't think that the researcher is doing something wrong. We don't think the students are giving wrong data on purpose necessarily. Okay, so let's talk about this. Due to your sampling variability, remember you're sampling and there's variableness in your sample, every random sample produces different estimates. And that is, yes, every sample population. And we talked about this in 3.1, gives different information. Okay, now you're hoping that every random sample population is going to be fairly close to the actual information. And again, the more you sample, the closer you're going to get to the actual answer. Okay, so this is making sure we understand margin of error. All right, so I'm going to send out your homework. You have 2 sheets on Google Classroom. These are due Monday, and we'll answer questions on Monday. Make sure you turn them in on Google Classroom.